All right, we're live. This is Knowledge Maps, and this is going to be our Fall 2019 end of quarter update. I'm Daniel,
I'm Salome.
and let's get started. Let's hit the window. Cool, so we'll start with a little bit of context and a primer on why Knowledge Maps exists. So the current problem is that we have a lot of advanced beginner web developers. These are web developers who are mostly self-taught and they want to become professionals. And they use a lot of online tutorials or self kind of teach resources that allow them to understand basic web development syntax, so in this case specifically HTML and CSS. But often what separates them from professionals is that they cannot utilize the professional practices and easily acquire the professional practices used by people in industry. So ultimately, the goal of knowledge maps and what we're trying to solve is that we want users to be able to easily identify and leverage these professional practices by way of professional examples. Not only identify it, but we also want users to be able to understand the trade-offs and correspondingly, once they understand the trade-offs, learn to apply these professional CSS techniques to implement new examples in their own time. So we have two major classes of related work here. So as I mentioned earlier, a lot of these developers and novices are ones who have used online platforms such as W3 Schools and Code Academy. And these platforms are good and abundant in the sense that they are effective as scaffolding novices to understand individual examples by way of live interaction with code. So consider this W3 school screenshot here where we're teaching the grid column property and the user can interact with the example. But as you can see here, because the example is also one line, it's very constrained, which thus leads to a shallow user understanding. It teaches more syntax rather than holistic understanding. Now, we also have tools like Ply, Telescope, and Scaffolded Exercises, which is great for helping users sense make, and that is to identify relevant code within a huge professional code base. And this helps them identify the effective code responsible for a particular visual feature, but that is essentially the extent at which it arrives at. It doesn't help the developer apply their knowledge and essentially apply the concepts and techniques across multiple examples.
As Daniel has mentioned, there are already tools that help users sense make, but the problem with these tools is that they teach users only one example, so users understand a technique based on the example they learned it from, and therefore they cannot transfer this knowledge to new examples. Our research question is how can we scaffold novices to effectively learn professional CSS techniques and apply them in multiple contexts. We employ a learning strategy of comparison and contrast, where we provide users with multiple examples and have them work through all the examples given. And by doing so, users understand the techniques in individual examples. They also understand the trade-offs between the techniques and how to apply a technique to a new example.
Cool. So it's been a very fruitful quarter in terms of contributions. So I'll quickly walk through the ones we're going to cover. So the first one is that we worked a lot on design arguments and kind of like designing a process for users to embark on. And this culminated in kind of like a process management design that we consider the knowledge maps learning process. So I'll walk through that in the design argument section. We also, once we figured out this process, went through low fidelity as well as higher fidelity paper prototyping and digital prototyping. And in order to implement certain interface affordances, which we'll cover later, this work and iterative design ultimately culminated in a digital prototype. With that, we also thought about how to kind of like abstract and automate a lot of our system. So we also came up with system and backend arguments to kind of like embody the affordances. And finally, because we're submitting to SRC, we conducted a big user study with 9 users, and we conducted some findings and learnings from the particular study. So a majority of users were able to identify the broader pro-con trade-off between the two professional techniques embodied in our CSS grid examples. We'll walk through them later. And process management mechanisms, which I'm about to describe, such as reflection prompts, code tinkering, and code highlighting, were useful in scaffolding users to understand this professional code. Now, ultimately, not all of our results were perfect, so users struggled with writing syntactically correct CSS code when asked to implement a particular professional approach, but we'll talk about future work and the analysis for why we think that's the case later on. So let's walk through design arguments quickly. So first, we have our visual outcomes. So the first stage is that we want users to identify the key visual outcomes for each professional example, and this is done by way of having them get an opportunity to interact with a professional example, which allows them to reveal the visual states. And this is coming across the obstacle where without having the users interact with the website and just having them look at it. So for example, if you're a user and you just looked at this particular website here, we don't allow the users to form a basis of the different visual states which they used for their particular understanding and curiosity. So after the user goes through, the particular states, for example, on the right here, we want users to be able to identify which CSS properties, so I'm just going to scroll through the prototype quickly here, they think are responsible for a particular visual outcome. So in this particular case, what properties given the code extractive implied might be responsible for the column layout here. And the obstacle here is that we want to provide some sort of structure where users are not misattributing the effect that CSS property has on the visual output. Sometimes we also notice that users often misjudge their understanding and make misleading assumptions, so that prevents them from reading documentation, and they kind of just carry this misleading assumption, and that carries over their holistic understanding of professional approaches. So part of the design decision is how do we counteract against that. Finally, once they understand the visual and the code, we want them to kind of think more in terms of the rationale. So the obstacle we're trying to overcome here is without tying the visual outcomes and code properties to consider the programmer intentions. So without considering programmer intentions, users will often struggle to identify the professional practices. They might tie it too specifically to just one code property without understanding what the overarching kind of like structure of the code is doing with regards to the visual outcome. So all of this summarize these three steps of visual, code, and subsequent rationale culminate in process management. And process management is essentially referring to our learning process where by partaking in this particular process, users are able to evaluate the different professional examples with regards to pros, cons, and reflect over the cases where each approach is appropriate. And this overcomes the obstacle that even if you partake in the whole process and identify the professional technique utilized in each example, they aren't able to dive deep into why and when to use each professional technique. So you can think of the outcome of this process management design argument as users being able to identify and apply their learnings.
For interface arguments, we came up with a few affordances that would help users understand the examples holistically. The first one was code highlighting. As you can see on the example, on the page on the right, we have two tiers of highlighting. The first is highlighting code properties that are shared across examples where the value is the same. In this case, we have the blue highlighted lines as display grid because they're shared on both examples. And on the second tier of highlighting would be highlighting properties that are shared but contain different values. And in this case, they're highlighted in green. This is the grid template columns, which is given values 1FR on the left, but given a repeat value on the right. The reason we need code highlighting is because users often spend so much time going through code trying to identify important code properties. Even after extracting relevant code snippets from Ply, for example, users would often focus on certain code properties that are not very relevant. Another affordance we had was code tinkering. This is where we allowed users to tinker with certain code properties that were important. In our case, this was the values applied to grid template columns. Users could change those values and then resize the window and see the changes on each of the pages. For example, if you change that to 6 REM, you can immediately see the effect on the page on the right. Yeah. By doing this, users are able to map the importance of each code property to its visual effect and therefore dispel any misconceptions that they may have. Another affordance we had a number of interaction affordances that encouraged users to interact with the page in order to discover important visual properties. The first one was the slider at the top. Without using the slider, users may not be able to recognize that the example on the left has a cap on the number of columns, while the example on the right grows the number of columns infinitely. And therefore, having a slider and prompting users to resize the page at multiple stages of the process helps them discover such important key distinguishing factors.
So now that we've gone over the interface arguments, I'll go over a couple of the system arguments. So the first one is the TinkerBoku properties. So we've displayed that here in like the code dropdown in the user interface. But basically the idea is that given the CSS code of two professional examples, how do we generalize the process by which we select properties to be interactive? And this builds off our interface argument of code highlighting, where for now we've decided that by selecting the shared attributes from the specific CSS code, so grid template columns, as Salome had mentioned, and making them interactive, the users are able to more easily understand the visual and technical contrast across examples, since the properties suggest that there must be something similar with an approach, but the values that you can change it with regards to suggest that you can tinker with it and really learn the different values. So following that, the first part was identifying the different properties. The second part is identifying the code tinkering values. So the obstacle now is that, okay, let's say we have the CSS properties, in this case, grid template columns. There are multiple sets of values that can be supplied to the property. So how then are we able to generate kind of like a subset of values that can demonstrate the greatest difference across examples? And we currently do that by pruning out the best values for users by creating a superset of values across the two different sets of like examples, and then identifying which supersets are possible. So in the hopefully clearest way I can explain it very briefly, basically the idea is if we have one FR, we swap the number of one FR, and if we have REM and one FR, for example, in this min-max, we change the values of each respective one. And in this case for autofill, we realized that we can put new numbers as well. So you can also substitute it with numbers. In this case, this web page is a little bit unresponsive, so we'll continue. Cool. So now we'll go over evaluation methods. So we had two sets of measurements in our primary study that we conducted. So the first one is core user understanding. So the core user understanding is kind of like the outcome that we're trying to target. And we graded this on a rubric scale from 1 to 4 based on how complete and comprehensive the user's response was. 1 being completely off and 4 being completely spot on. And one question from each example was on whether one professional technique can be leveraged to implement the other. So for example, in one particular example, we are asking whether the user can implement this example of icons on the right with the app media queries on the left. Finally, we have affordance utility measurements. So what these are measurements that primarily for the reflection prompts within our tool. And this pertains to specific affordances too, also provided by the prototype. So in our tool, this consists of the different questions that we ask, but also we ask questions at the post-study survey that pertain to specific affordances that were offered by the tool. So reflection prompts, code tinkering, and code highlighting. And to solicit specific user feedback, we ask how the specific affordance provided helped the user, and also allow the user to rate how helpful the affordance was.
The results from our study shows that by using the knowledge maps tool, users are able to identify trade-offs between techniques. We had a number of users stating that the first example where we use that media queries would be most suitable for cases where you have a specific number of interfaces you're trying to program for. And in the other case, it would be for when you have an unlimited number of interfaces, so you want to generalize and make it automatic. However, users are not able to write correct CSS code for implementing one approach using for implementing an example using the other example's approach. And we suspect that this is because we did not give users live coding abilities to be able to dispel or correct their code on the spot. Another finding was that code tinkering helped users understand code properties. A lot of users said that by tinkering with the code, they were able to map specific code properties to the effects on the page, because once they changed a value, for example, if you changed a value there, it changed immediately on the page, and you could make that connection quite easily, as opposed to reading about it on documentation. The reflection prompts also helped users think critically. Users said that by answering the questions, they had to explore each example more deeply to be able to understand them and answer the questions. And also it helped them consolidate their knowledge at each stage. Code highlighting was a double-edged sword, where on one side it helped users focus on specific code properties, and therefore they did not get information overload. However, Sometimes users focused on the highlighted properties and did not look at other important properties such as the @media query, which is important for the implementation of example 1, but is not but because it's not shared between the examples, it's not highlighted.
Yep. So kind of like moving on to discussion following our study results. So we believe that the combination of kind of like the learning processes and different stages used in the knowledge maps tool was overall effective in scaffolding users to identify the distinguishing features between examples, the professional techniques, as well as the trade-offs between the CSS techniques. Now, however, the current set of affordances was not sufficient in enabling users to write the syntactically correct CSS code to implement the techniques learned. So we have a very strong kind of like signal that users were able to discuss trade-offs at a broader and kind of like design level scale. So they were able to have some positive takeaways and overall opinion. However, they couldn't write CSS code immediately on the spot, partially because we didn't give them a feedback system as we currently suspect. Currently, so for some next steps, the most pressing one, I believe, is to implement live coding for applying a learned CSS technique onto a new example. So for example, kind of like providing a code editor if we were to implement the first example on the left using @media query for the example on the right. And that would come with like its own set of challenges, especially in the system arguments section of like how we would support that. Furthermore, we also want to apply the knowledge maps process management affordances to new sets of examples to prove its validity and its worth. Because currently we have a set of examples where the examples look very similar in the sense that they're just grid examples with different numbers of columns, but are implemented differently. However, we haven't really considered, for example, CSS Flex, which is another layout type of library, or different approaches which allow for visually similar examples. And this will also help us assess the extent to which automation can attain the same outcomes. Furthermore, we want to further refine the system arguments to apply to a greater set of professional examples. As I said earlier, we have used some relatively a little bit more primitive, concrete examples for this particular set of examples for the code. But if we were to introduce different sets of examples by integrating with apply endpoint, which has its own set of associated challenges, we would have to apply existing code selection and tinkering selection to new sets of examples. So key takeaways: the process management mechanisms utilized by knowledge maps are effective at scaffolding users to understand examples holistically. By employing the compare and contrast, so like having examples on the same page and having users compare, knowledge maps is able to scaffold users into understanding trade-offs between CSS approaches and identifying the practical use cases. But we're curious as to what extent the existing process can apply to newer, more complex sets of examples. And we've talked about it, but we want to expand to both different visual examples with similar techniques and different visual domains of web development, not just focusing on layout.